Today we're going to be talking about the distance formula and how it relates to Pythagorean theorem. So let's first talk about Pythagorean theorem and what it is. And if you remember from what you've learned before, we know that Pythagorean theorem is a squared plus b squared equals c squared. And this is all built on a right triangle. I'm just going to freehand this right here, where a and b are the sides of your right triangle, and then c is our hypotenuse of the right triangle. And so there we have our Pythagorean theorem. So now that's going to help us actually derive and come up with the distance formula. So this little packet is just going to take us step by step to do that. So in this next problem, we have point A, which is at 2, negative 3. I'm going to label that point A. And point B, which is over here at negative 5, negative 3. And there is point B. And if I'm trying to find the distance between A and B, I can literally count over from negative 5 to positive 2, and I find out that this has a length of 7. Now I can count the squares, or I also could notice that this was the same thing as finding the difference between those values, but we'll get to that in just a minute. Now, if we look at this next example, we have two different points. Point C, which is at negative 2, 6, that's point C. And then point D, which is at negative 2, negative 4. And again, if I just join those 2 points and try to find the distance between those 2 points, I can just count and find out that the length of CD is just going to be 10. So now let's just continue on. We're looking at a few different examples to just kind of build on. Here we have a point E, which is at negative 1, 5. So this is getting a little bit more interesting, and I'll show you why. Because point F is at 2, 1. And so we don't just have a horizontal or a vertical line like we did before. Now we have this kind of slanted line, and we've got to figure out how we're going to find the length of that. And so what it has us do here is first it says draw a horizontal line through point E. So I'm going to draw a horizontal line that goes through point E. And then they want us to draw a vertical line that goes through point F. So there I've got a vertical line. I didn't do such a good job drawing that, but a vertical line that goes through point F. And they say that connect those vertical and horizontal lines at the intersection, which they call point G. So if we look here on our graph, if we're trying to find, they first say find the length of EG. So EG, which is right here, if we just count across, we see that that just has a length of 3. And then they ask us to find the length of FG right there, and if we just count our squares, we see that that length is 4. And so now if we think about it, if we have a horizontal and a vertical line, those are going to meet to form a right angle. And so we end up having a right triangle here. So can't we take the two sides, the 3 and the 4, and use Pythagorean theorem? Remember, Pythagorean theorem is a squared plus b squared equals c squared. So here we have 3 squared plus 4 squared, and it's going to equal that third side. And so, which is just EF. I'm going to call it EF squared. So 3 squared is 9, 4 squared is 16. 9 plus 16 equals 25. So we know 25 equals EF squared. So EF, that length of that line there, is just going to be 5. So we know the length of EF is going to be 5 using the Pythagorean theorem and what we know so far. So let's do another example. So here they tell us that J is negative 7, negative 4. So that's point J. And they tell us that point K is negative 1, positive 4. So that's K. So we're trying to find the length here. And it says we can draw a picture if we want to draw our horizontal and vertical lines, We could count the squares and get these distances to this point and use Pythagorean theorem to figure this out. So if I do that, I notice that right here, this length is, that's a really thick pen. Go back over here, this is 6, and then going up here is 8. So if I'm trying to find the length of JK, I could do 6 squared plus 8 squared, and that's going to equal my JK squared. 6 squared is 36, 8 squared is 64. So we end up finding that 100 equals JK squared, so JK is equal to 10. So now we're getting somewhere. And what they want us to do now is try to generalize what we're doing. How are we coming up with the distance between 2 points? And so they said, what happens if you end up having these generic points L and M? So let's just say that this is point L, and they tell us that the coordinates are x1, y1, and then let's say we have a point M, and our coordinates are x2, y2. Now, what we have in essence done, like up here at the previous one, when we found that this was 6, we were really just taking the difference in our x values. So we could generalize this by saying that we have x1 minus x2 squared. So we're just taking the difference of our two x values plus the difference in our y values, y1 minus y2 squared, and then that's just going to equal whatever distance we're trying to find, the distance squared. And so this has helped us come up with the distance formula. Many times, instead of seeing it in this way right here, we'll see it solved for just d, and so we'll say d, which is just stands for your distance, is just going to be the square root of x1 minus x2 squared plus y1 minus y2 squared. Now, some of you may have said in here instead x2 minus x1 and y2 minus y1. That's equally correct. My thinking question for you all would be, why is that still the same thing? You could do it either way, but why is it still the same? Why would you still get the same distance? So think about that. So now we just have a few examples. So why don't you pause the video, work on these next few, try to work off them algebraically, and then come back and take a look at the video and look at the answers. So now you can check your answers for number 8 for part A and part B. You should have found the distance to be 13 and 25. And now when we move on to part 9, it wants you to go back at these numbers 4, 5, and 8 and see what the sides of the triangles are. And you can notice that I put these in blue. So I really just kind of drew the triangles that we were using and put the lengths of each side. So here we had 3, 4, and 5. Here we had 6, 8, and 10. 5, 12, 13, and 7, 24, 25. So we had 3, 4, 5. We had 6, 8, 10, 5, 12, 13, and 7, 24, 25. These triangles are important. We call them our Pythagorean triples, and we will talk about these more second semester. But I did want you to go in and see those today, those special kind of triangles. So now let's take a look at how the distance formula applies to circles. So a circle is actually defined as just a set of all points that are equidistant. Equidistant just means equal distance from a fixed point, and the fixed point is the center. And the distance from the center to a point on the circle is just called the radius. We're familiar with that. So now we're going to use our knowledge of the distance formula to come up with the equation of a circle. So here they ask us, to draw a circle with the center at the origin. The origin is just going to be at 0, 0. And they tell us that the radius is 5. So I know if the radius is 5 that we have to have a point on the circle right there at 5, right there at 5, over here at -5, and then down at -5. And I'm just roughly sketching it. This does not have to be exactly correct. It's just kind of a rough sketch. I'm going slowly so it looks like an amoeba kind of. Okay, so we've drawn the circle here, and they then asked us a question: would this point 3, 4 be on the circle? So let's look. What if we plot that point 3, 4? Well, in my rough drawing, it looks like it's on the circle, but how do I know? If you haven't answered this on your own, I want you to try to answer it, and then you can come back and take a look at my explanation. So once we have that point 3, 4 plotted, we can actually draw our horizontal and vertical lines here, and then the point from the center of the circle to that point 3, 4. And we notice that it ends up creating this triangle right here where we've got 3 horizontally, 4 vertically, and then this slanted line. It actually, if that point is on the circle, that slanted line would be our radius. And we see that it does in fact check out, and so we do know that 3, 4 is a point that is on the circle. So what we have done is we've actually come up with an equation of the circle. We just used the distance formula right here, right? We said this was equal to d squared. And when we knew d squared equals 25, then we know that our distance was 5, which is the same as the radius. So instead of having the distance d squared, we can substitute in r for our radius. And many times we will see this as written just as r equals the square root of, and then we would just plug this in. I want to point out, when you are talking about the center of the circle, you typically denote that as the point h, k, and then any point on the circle to be x, y. And so here we have the formula for the radius, and which is considered the formula for the equation of a circle. So we have the radius equals the square root of x minus h squared plus y minus k squared. And again, this is where h, k is the center of the circle, and x, y is any point on the circle. And of course, we know that r is going to be our radius. And so we can use that formula to find different parts and pieces depending on what we're given. One thing I do want to point out here is that many times you will see the equation of a circle written like this. Here, where you have x minus h in parentheses squared plus y minus k in parentheses squared equals the radius squared. So it's just rearranged just a bit. And we can use that standard form of a circle to find our center and our radius pretty quickly. So I want you all to go through these next few problems, see if you can identify the equations of the circle and the center and the radius, and then come back and check your answer. So a few things that I want to point out here: be really careful, like on this second one, the y value of the vertex, or that k value, is going to be 0 because we're not subtracting anything from y. Same thing here for both x and y. So our center was just at 0, 0. Another thing you have to be really careful about is when you have x or y plus a number. If you look at the standard form of a circle, it's x minus h, so it's always going to be the opposite sign here. So just be careful in those particular areas, and once you're done with this, you can move on to the next lesson.